I will start with the overview of the project. So first, we read through some article and determine the project title for improvement. So the title we choose here is Speech Recognition Writing System using STM32 microcontroller with CNC NN. Yeah. So from the original article, the speech recognition is not inside the article. So we choose to use the speech recognition. The switch we use is the on and off. When the system detects the on and off, it will turn on or turn off the write. So the first thing we need is prepare the component. The component we use in this project is STM32 and microphone. So then we need to install the software. The software we use here is Khoo IDE. Yes. Then after installation of the software, we need to correct the data. The data correction is we correct the on and off. After the correction of data, we train the model. After that, we deploy the model into STM32 using Khoo IDE. Yeah. Then after that, we test the model, see whether it's working or not. So if it's working, then we end out we report writing. If not, we will go out again and correction of data and train again the model.
Okay, let's proceed to the part where how to train the model. First, we use the speech command dataset from Google. We can see here that the dataset is randomly shuffled. 80% is the training data and 20% is the test data. This is because models might overfit the training data, so we need to test with unseen data. So they will consist of 4 categories, which are on, off, unknown, and the background noise. Then, we use the MFCC to extract the features from the raw audio signal. The output of MFCC is this, the two-dimensional array that looks like an image, where we use for neural network later. So this is the neural network architecture. We start by using the default 1D convolutional first, then only do some fine-tuning to add some extra layer to improve our accuracy. So we start, build, and train the model. This is the performance that shows the confusion matrix to show the accuracy from the trained data set. For the unseen test dataset, we reach an accuracy of 80% for our model. Last but not least, we deploy our impulse to a C++ library so that we can run on STM32 microcontroller later.
Okay, now I'm going to explain about STM32. So after we got the trend model from the edge impulse in terms of C++ code, then we are using the CMSIS library to actually deploy our model into a microcontroller board. So the IDE we use is the STM32 Cube IDE, which is shown here. So I'm going to explain the peripheral initialization we use in our project. The first one is the GPIO init. The second one is the DMA init, which is for the memory access. The third one is the USAT init, which is for the serial communication. And the following one is the CRC init for the buffer operation. And the last one is the SAI init, which is for the communication between the mic sensor and the board. So next, I'm going to show the main core of our project. So here actually the core is to compare between the buffer data with the model data. So if the on keyword is more than the threshold set here, then actually the board will turn on the LED through the GPIO pin 7. And when the off keyword is above the threshold 0.5 here, then the board will turn off the LED. Next, I'm going to show how actually we are going to build our project. So you just click on the build project here and then wait for it to be complete. So this step is to compile and to link the project and to produce the object file. So after the build is finished without error and warning, so we can click on this run button to actually download the object file into our board. And then next will be our demonstration on our project, and that's all from our team. And enjoy the demonstration. Thank you.
On, off, on, close, open. Hey, hey, hey Siri. Close, off, off.